Hello, everybody. We are starting our new chapter today, which is going to be over circles. Whoop, whoop. Okay, it's our last chapter, and then we'll be done for the summer. I've also figured out how to add Bitmojis to our presentation, so yay! All right, before we get started into our circles chapter, one thing that's going to be essential for this chapter is vocabulary. This chapter is extremely vocabulary heavy. So this first day, I'm going to be introducing a lot of terms, and then throughout the chapter, we're going to be applying those terms. And we're going to have 1 to 3 days of practicing those terms and really nailing down this vocabulary. Okay? So make sure you're paying attention as we're going through this information. All right. A circle is composed of a lot of different parts, and all of those different parts have particular names. You may have seen some of these in the past, and now we're going to be using calculations with those. So, a lot of us know what a circle looks like, but the geometric definition is it's going to be a set of points that are equidistant from a given point, being that center. We analyzed this relationship with spheres last chapter. If I'm wanting to name a circle, I will, that identifying mark is going to be that center. So we call this example circle P. Radius, we've looked at this definition before. A radius is going to be a segment with endpoints at the center and on the circle. So our examples here would be segment AP and BP. A chord, that's going to be one of those new terms. A chord is going to be a segment with endpoints on the circle. Specifically, a chord typically does not fall through that center. If the chord fell through that center, we would give it a further classification of diameter. So if it does not go through the center, we call it a chord. If it does, it will be your diameter. So for example, in this example, our example for a chord is JK, and our diameter is BA. Is BA a chord? Well, yeah, but because we want to make it a little bit more specific, because it goes through the center, we call it a diameter. All right, not too shabby. All right, some more vocabulary. A secant. A secant is going to be a line that intersects the circle in 2 places. So it's a line, meaning it continues through the circle and outside of the circle and has those arrows on the end. So in this example, our secant is line YZ. And remember, when we note lines, it's going to have that kind of arrow notation above the points. If we have a line that's outside of the circle, it's typically outside, it's going to be a line that intersects in exactly one place. That's going to be a tangent. And that point of where it intersects the circle, in that one spot, that's called the point of tangency. So in our example, our tangent is PR, line PR, and then our point of tangency is Q. Okay. A central angle. A central angle is going to be an angle with a vertex at the center. And 2 sides are radii. So right here, this is the radius, as well as this the radius. And because those are both radiuses, radii, okay, they are congruent because they meet in the center at point P. And it forms a central angle. If that angle does not meet at the center, so its vertex is not at the center, but the vertex is on the circle, okay, and its 2 sides are chords, they're not radii, okay, that's going to be an inscribed angle. So if the vertex is on the outside of the circle or on the circle, it's inscribed. If it's in the center, it's called a central angle. All right, last page of terms. An arc is going to be a portion of the edge of the circle defined by 2 points. Right? So it's basically kind of, I like to think of it as the crust of your pizza. The crust of your pizza is your arc. We break up our arcs into two categories, one being a minor arc and one being a major arc. Whenever I hear arc, I think of a dog bark. Arc, 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 arc. Or maybe a seal, maybe. Oh well. Okay, a minor arc is going to be a measure that is less than 180 degrees. So when we write or we note minor arcs, we only have to use 2 points. A major arc, that's when you have a measure greater than 180 degrees. Now for major arcs, we have to use 3 letters to kind of note the direction around the circle. Because for example, so my major arc is in blue here. Okay, it's that movement around the circle. If I just name that AC, well, that's that minor arc right there. So for major arcs, we have to have 3 points in our name so we know the orientation, the direction around the circle. And then finally, a semicircle is an arc with endpoints on the diameter. And it's always equal to 180. So it's that pizza cut in half. I know that was a ton of vocabulary thrown at you in a short amount of time, but I wanted to get you guys the basic definitions because we're going to be using equations with those terms throughout this chapter. And you're going to get practice identifying what those terms are. All right, a little bit of review before we jump into this. Our circle formulas for our area. Area in a circle is going to be equal to pi radius squared. And then your circumference is going to be equal to 2 times pi times radius, or pi times diameter. Okay? And we're going to be using forms of those equations later on. All right, so let's actually get into some calculations. Let's do some math. Our center angles, a little bit of refreshers. Our central angle is going to be those angles that meet at the center of the circle, and its 2 sides are radii, meaning those 2 sides are congruent. If we add up all of our central angles, it will equal 360 degrees. So, for example, okay, let's look at this example. ABC is 84 degrees. If that's 84 degrees, what is this angle on the opposite side going to equal? Well, I can take 360 minus 84, and that opposing angle is going to be 276 degrees because I took 360 minus 84. Now, the one unique thing about central angles is your central angles are congruent to the arc that is formed by the endpoints of that central angle. So if this central angle is 84, this arc measure is going to be 84 degrees as well. If this central angle is 276 degrees, this arc measure is going to be 276 degrees. So arc AC is equal to 84 degrees. Arc ADC is equal to 276 degrees. Hold out your arms. Think about this for a second. If I measured that angle between your shoulder blades, that angle is going to be the same measure as if I measured the angles at my fingertips. So that's the relation between your central angles and your arcs. My central angle is that kind of inner portion at my shoulder blades. My arc is at my fingertips. So let's do an example of this. All right, we are going to try to find the angle and arc measures. All right, and using these properties we've analyzed with angles. First off, typically what I like to do, I like to solve the picture. It may not be the fastest method, but it's kind of your way to find your puzzle pieces. Okay, so immediately I see the only quantity we have is 19 degrees. All right. My first thing I'm wanting to find is PQ. All right. How can I find PQ? Okay. How do I find PQ? Well, if my central angle here is 90 degrees, what's the measure of TS? That arc is 19 degrees as well. Okay. What is unique about your diameter? What's your diameter going to do? Well, it's going to divide that circle in half. What's the measure of a semicircle? What's the angle measure? 180 degrees. So what is the arc measurement of RST? Well, that whole arc is 180 degrees. So if I were wanting to find RS, I could take 180 minus 19, giving me 161. Is that one of our things we needed to find? Yes, we need to find SR. So SR is 161. All right, so if TSR is 180 degrees, what's going to be the measurement of TPR? So this other half. Well, that other half is going to be 180 degrees, okay? But is that going to help us right now? Not really, okay? So let's back up here. I am wanting to find PQ. How do I get to PQ? Well, first, I note that this angle right here is 90 degrees. So PQR is 90 degrees. But I need to find one portion of that. Can I find QR? Arc QR? Yeah, I can. Remember, what's this relationship called? Vertical angles. So QR is going to be 19 degrees. Now that I have QR, I can find PQ by taking 90 minus 19 to give me 71 degrees. All right, what's next? I'm trying to find arc QRT. Well, I know the measurement of QR. I know the measurement of RT. RT is RST is 180. So 180 plus 19 gives me 199 degrees. My next arc to find is PSR. Whew. Well, without even looking at any measurements, what's the angle measure all the way around the circle? 360 degrees. Okay. What's my measurement of PQR? 90 degrees. So 360 minus 90 degrees will give me PSR, which is 270 degrees. Finally, I need to find PS. Well, I know PS is, I know TS is 19 degrees, but I don't know PT. Can I find PT? Yes. Okay, well, segment RT is a diameter. So if this portion is 90 degrees, what's this portion going to be? That's going to be 90 degrees as well. So to find PS, you can take 90 plus 19 to give me 109 degrees. All right? I know that sometimes when doing these problems, it can be confusing, especially with all the different segment names. So if you need to rewatch this example a couple times, I probably will if you are a little bit confused, because there's no crystal clear path when taking these. There's multiple ways to solve for different angles. So if you found a method that works better for you, use it, okay? All right, one more section or one more part of these notes is going to be arc length. We are wanting to try to find the length of an arc. And we have this formula. Your arc length is going to be used by kind of like that cursive L, and that's going to be equal to X times C over 360 degrees. What does X mean? X is the degree measure of the arc, so that central angle, or that outer arc angle, multiplied by circumference, okay, divided by 360. So one thing I do want to note, going back to our previous example, when we were finding those angle measures around the outside, okay, that's not the arc length. That's the arc angle measure. Okay, so make sure you don't make that confusion when you're solving for different problems. So arc length is going to be the degree measure of the arc times circumference divided by 360. Okay, so let's do an example. First, I'm going to write my equation. L equals X times C over 360 degrees. Find the length of the bolded arc to the nearest hundredth. So I highlighted it in yellow. All right, to find arc length, I'm going to multiply my central angle of 107 degrees times circumference. What is circumference equal to? Pi times 2 times r, or pi times diameter, My radius is 6. So I'm going to take my radius times 2, which is 12 pi, divided by 360 degrees. Okay. So 12 times pi times 107 gives me 4,033.8 divided by 360 to give me an arc length of 11.2. And she wants to round to the nearest hundredths, so 0.21 will be my final answer. What will be my units here? Meters, because my radius was given in meters. Okay, one more example for the day. Find the length of arc CD. So arc length is equal to x times c all over 360 degrees, or 360. I'm wanting to find this measure right here. All right, where's my x value? My x value is here, okay? And I need to find circumference. Okay, circumference, in order to need circumference, I need my pi times diameter. So what is my diameter? It's going to be 15 plus 15. So my diameter is equal to 30 meters. So we got that. I just need to solve for that x in order to find my arc length. How can I solve for x? Well, remember that property when we have a line and we have one angle? How do I find that other half? Well, that line degree measures 180. So I take 180 minus 68 to give me 112. Now that I have that arc measure, I can plug and chug. So L is equal to 112 times pi times 30 divided by 360. So 30 times pi, top her into my calculator, times 112 divided by 360 gives me a final arc length of 29.32 centimeters as my final answer. All right, I know I threw a lot of vocabulary at you today, and we're going to get tons of practice identifying those terms and applying it. We did calculations of central angles, and arc lengths. Okay, if you have any questions, please let me know. I am here to help. See you guys.